Yes, it's okay. You heard that? This meeting is being recorded. So welcome to this online roundtable conversation at SPARK. This is an open link, so people may drop in and drop out. It's open till 3 p.m. and this is the first time we host this thing online like this, so it's an experiment. We'll see how many people that shows up. I have no idea. Now we are 9, so that's pretty cool. I welcome all of you. I need to say that this talk will be recorded and uploaded on the SPARK webpage. Thus, by attending, you agree to this, basically. But my name is Per-Johan Dahl. I'm an associate professor at the Department of Architecture and the Built Environment at Lund University. And I will act as the moderator for this talk. And the link is active till 3 p.m. So that's a harsh deadline for the talk. So SPARK is a collaborative platform with the purpose of strengthening the interface between architecture, art, and societal advancement and research through exhibitions, lectures, talks like this. The aim is to promote artistic processes in urban development by activating intersections between art, architecture, urban design, and landscape architecture. And SPARK collaborates with the Department of Architecture and Built Environment at Lund University and with the Molecule Gallery. And SPARK is generally supported by Architect Sweden Scania. SPARK's objective is to exhibit works and agencies that provokes critical discourse in current city building through explorative, experimental, trans and interdisciplinary practices. And I don't think anyone could match this objective better than Ana Goidea, whose exhibition Xenoikos Hidden World has been on show since October 30, and it closes today. So if you haven't seen it, you still have a couple of hours to run to the gallery. Ana Goidea is a designer and researcher currently advancing her doctoral thesis at the Department of Architecture and the Built Environment at Lund University. She has an extensive background of working with emerging technologies such as digital computation, 3D printing, and robotic fabrication. And her research positions itself at the intersection of architecture, technology, and biology. Today we are happy to also welcome Jessica Abbott. Jessica is a senior lecturer at the Department of Biology at Lund University. And Abbott's research includes interdisciplinary collaboration about new forms of life, where she studies how humans shape and are shaped by the life forms around us. And this research includes, for example, the extraterrestrial, artificial intelligence, and synthetic biology. And I also asked David Andréen to support this conversation. David is a senior lecturer at the Department of Architecture and the Built Environment at Lund University. His research revolves around topics such as design for additive manufacturing, algorithmic design, ecology, and environmental engineering. Welcome everybody. I thought we run this as a kind of collegial conversation. We have a lot of intelligence in the room here. I think I'm kicking this off with a few questions, and then after a while we let the audience in, and hopefully we'll have a great time here for the next couple of kind of 55 minutes. So if I start here by just posting a question, the talk will of course revolve around Ana's exhibition at the gallery, and the exhibition combines different medias. There are objects. The object, we have the media of the movie, the sound. And also, I mean, I would argue that the materiality of the exhibition, like the stripped backdraft and the black walls also together kind of create and instigate a total experience. To me, the exhibition describes almost an analog of immersive environments where the non-human actors, I mean the fungus, serve to challenge or to reconceptualize the way we think about aspect of scale, space, and velocity. And as one of SPARK's members, I've been there quite a lot during these last couple of weeks, and I've been thinking about the aesthetics behind the exhibition. So I'd like to start to ask Ana and perhaps open up the floor for conversation about the aesthetics of this exhibition. What was the aesthetic intentions of crafting the exhibition through these different medias? I mean, how do you see them interact in terms of aesthetic?
Yes. Yeah. So I think generally in the work that we do at our group, and also through this project and then others, we're really looking towards processes in nature. So to try to learn from that and be inspired, and of course study and then see how we can implement them in different ways. So I think I wanted to kind of communicate that through the exhibition and through the way I set it up, and then perhaps move the focus away from the means of production and through like digital fabrication and all the other tools to the other elements that are part of the production. So through, you know, the living agents that are that we are collaborating with in this project. So I wanted to show, so you know, maybe generally the way we think of nature is more this kind of nature with capital N, right? Like large mammals and forests and things that are, you know, fascinating and all of that. But I think so much of that happens at very small scales and very like spread over time processes. So I kind of wanted to kind of bring that into focus somehow. So things that we generally tend to maybe not reflect so much upon, or kind of tend to be all put under, you know, microbes. Of course, you know, there's plenty of reason to be kind of fearful and kind of for that, but there's also so much to learn and be fascinated for, and kind of embrace a lot of like interesting things that happen in that. So I wanted to kind of shed light on that. So by bringing, you know, I think the medium of film has a lot of power for that. So kind of it's able to bridge, you know, scales and spaces. So through the microscope, I wanted to bring to the human scales things that happen at vastly different scales in time and in space. So by zooming in and scaling up and then speeding up as well, to see these processes as alive and happening, and, you know, full of in ways that we can relate to them as humans, right, on a very kind of immediate sense. So I kind of that's why I also wanted to scale it up, the video, so that it happens almost one-to-one on a human level, the hyphae, the root system of the fungus. So, and also because I didn't want to hide the fact that that's how it's made, right? And then the role that these agents had in the production of the piece, of the column. And also kind of, if you kind of more practically in terms of the material and all the other elements, right? Like the projection on the string curtain, right? I kind of, instead of projecting on a you know, clearly defined homogeneous geometrical panel, right? I kind of wanted to kind of bring that kind of a bit of the nature of the unstable ground, the multiplicity, like of it, and the movement, to kind of denote that, you know, that fluidity that happens, and to kind of bring it a bit more to be more felt, right? It's kind of, the bathroom was behind and people can go in and out, and kind of the overlapping of of microorganisms and humans, that kind of the projection on the people as they go in and out and as the curtain moves. So I kind of wanted that to be part of the experience. And also the mirror above the column, again, to kind of another hidden world that happens within, right? Because the column is made by microorganisms just as much, and they're not just on the surface where they can be seen, but all in the inside is filled by their presence, right? And their forces. So, and it's different. All the channels that are inside are not so clearly visible from the inside. So I wanted to show that hidden part of it as well. Yeah.
Yeah, I was personally really fascinated. I mean, one of the objectives we've had with SPARK is to communicate exhibitions also in the urban space. I mean, the space of the city, which is outside of the gallery. The gallery is so great that it's on a corner location with two glass walls. And to me, I mean, these juxtapositions in scale when it comes to fungans and the micro, what do you call it, the microscopic kind of environments that you manipulate in scale. I think it worked extremely well, and I would be interested to hear Jessica here. I mean, what did you think? Because as I understand, you've been quite involved in kind of media.
Yeah, that's true. Yeah, I thought that was really effective, showing the growth of the fungus and doing time-lapse photography to show how it looks when it's at a kind of time scale that makes sense to us. And this is something that as biologists is often like a practical challenge, actually. You know, how do you measure something in a way that we can make it understandable for us, and what do we miss because things are happening either too fast or too slow for us to really capture them? Because I mean, your senses are still your best tools in terms of, you know, trying to see patterns and use the information that you take in about your study organism to come up with hypotheses. And so this is something that's, you know, not just like interesting from the point of view of showing the public how these things look when they grow. It's also really important to try to find the right scale as a researcher to be able to actually see what's going on and actually see, like, is there something here that we were missing because it's happening too fast or too slow? And plants are very dynamic, you know, organisms as well, but we tend to think of them as being very static just because they move on a scale that's so slow that we don't notice it.
That's so true.
It's interesting that biology and architecture, I mean, the means of representations obviously connects us. I mean, how to visualize things that you imagine, or that you kind of are generative, that are difficult to comprehend. But you know, what did this do to the visitors? I mean, were there any differentiations between visiting the exhibition inside the gallery or out in the street? I mean, what would you say? What was the impact on the visitors, basically, in different locations?
Yeah, I think, I would also like to know that, actually. The way I thought of it was that it can be seen and experienced at some level from the outside, right? And kind of the large projection and large windows and the visibility from, as you're saying, around the corner. You can both the column and the video can be seen. But I think I wanted to be a bit more immersive, so kind of more to draw people in and to kind of be that maybe you get something from just seeing it from the outside, but I think the whole story kind of develops as you go in, and kind of, I think also the sound ties the two together, and how the column reacts through the sound, kind of reacts to the video and kind of links them too. So I think, I think the story makes more sense from the inside than from the outside, I guess.
What do you think, Jessica or David? I mean, like any good exhibition, I think you discover things. I mean, when you move between the different scales and in close contact with different kinds of materialities or objects or media, let's call them media, you discover things. Like the mirror was so arcane yet really effective, like a piece of mirror in the above this column. It really, I think it was kind of Jurassic in a sense, but still, I mean, we have materialities here. We have physical objects, and still, to me, it really wasn't or isn't emerges an immersive environment. I mean, how would you say, Jessica, in relationship to artificial intelligence, and what do you? I mean, would you see this being successful in such an environment, or do we need the materiality here?
Well, so yeah, so a couple of different reflections that I could say here is that I went to the gallery on Friday and I read, the material that Anna had sent me on the train on the way there. So I knew quite a bit about the process and all of the sort of technical aspects. But to actually go there and to see everything in person, and to even be able to touch the column, that was really cool. And I mean, I was talking about us taking in information, from our senses, and of course this is the way we've evolved, is that we want to take in different types of information, and it becomes much more effective and makes much more of an impression when you can have multiple sensory modalities at the same time. So for me, that was completely a different experience than just reading about it, and I thought it was really exciting. And I really liked, of course, the mirror in the roof, as you say, because I mean, in cross section, I think the design is really pretty beautiful of the column, and it's nice from the outside as well. But you really do miss something if all you see is the outside. You don't see all of this complexity on the inside. So I thought that was really exciting. And when it comes to artificial intelligence, I mean, I think that this is one of these things that's really interesting in terms of the interdisciplinary research collaborations that I've had before, is linking technology and biology in some sort of way, so that Anna was saying that the design of the column was based on these sort of diffusion equations that's similar to the sort of things that you see in pattern formation during development, and I can see that. I recognize like this sort of organic type of form, and I think it's really amazing to be able to use technology to produce something that looks and feels so organic.
Yeah, because actually I think that was something that I think we had in mind quite from the beginning, to kind of what is, because it's a new type of material that's kind of, we're still discovering its properties, its kind of potential application, what are the limits, and what can we do with it, right? It has a lot of promising potentials, but it's not there yet in terms of what it is, and how it can be, how it can be placed directly in the world. So I kind of, with that kind of discovery of it, we also had to create a bit of a language. How does it express itself, right? A material that's like some of the things that we relate to, on a core, more like sensorial basis, like a bit like wood, or a bit like some sort of organic materials, but it's not exactly like wood, right? And its expression, its texture and its ductility is not of wood. So then what would it be? It's kind of, how does it want to manifest itself, right, in space and in geometry? So kind of that's what I wanted to kind of convey through, I mean, the higher precision of the means of computation and the scales that it can reach and fabrication, but then also a kind of a nature of expression that is hints to its nature.
I thought there was something really interesting in Anna's response to the kind of the aesthetic design of the exhibition, so to speak, and particularly the role of the mirror. That's interestingly we can't talk a lot about, in that, because you said, Anna, that it's made by microorganisms, and that's kind of shown in the aesthetics. And I think there's something really quite, of course, it's made by the actions of the organisms, and we're kind of, enslaving them or whatever to make this structure for us. But it's also kind of made by their needs. So especially when you start looking at the inside of the column and you're starting seeing how these curves happen, they're not just there because they mimic the way nature looks. They're actually there because they're a requirement for the life cycle of the organisms that are making it. So it's not only the actions of the microorganisms that are there, it's actually their needs and their demands which are shaping the way this looks and the way that it operates and functions in a human environment, which I find, kind of mind-blowing in a way when you start really considering it.
Yeah, that's so true. It is a negotiation of needs, right? Kind of what are the needs that are human scales and of the use of this architectural element, but then also at a much smaller scale, what are the needs of the organisms? And exactly as you're saying, the design kind of had to take both into and kind of negotiate through the means of like algorithmically and iteratively kind of how to best fit both these two within also the constraints of the production.
Yeah, no, I was of course, like most visitors that I talked to, was very curious about why the shape, and kindly David, it took me around up there one afternoon explaining, I mean, what role the shape actually have. Like you said, David, I mean, there are logical reasons why it has the geometry it has in several ways. But I've been thinking about this. I mean, also the column is quite small. And I mean, how do you, Anna, and perhaps David could also join in here, but I mean, particularly Anna, of course, I mean, how do you think about upscaling the column? I mean, are there any possibilities of doing this? And I'm thinking quite pragmatically. I mean, what kind of loads does it take? Lateral loads or vertical loads? How durable is the material? I mean, could it stand outside in the rain here in Malmo? Well, now it's a nice day, but I mean, these questions, these very pragmatic questions, how do you think about those in relationship to the materiality of the column?
Yeah. I mean, it's true. I mean, the column, it's all relative, I guess, right? So relative to urban scales, it's quite small, but relative to the, molecular scales at which a lot of the things happen, it's quite, it's quite large. So I think I think that was to scale up using from such a, bottom-up principles in terms of organizing and distributing and kind of integrating needs of such small scales. It's quite large, and those are the first question we wanted to ask by this research was, is it possible, right? Can we scale up to architectures from biological? So in that sense, the answer was yes, right, through to realizing this. But then of course we we do want more, right, and we seek larger and kind of wider applications for it. And I really hope we do get to that. I mean, of course, as it is now, there's lots of things that still need to be optimized and tested and refined. And I mean, there's a lot of literature, like relatively a lot, in terms of understanding the material properties of lignocellulosic materials in combination with fungus, right? But most of them are done in different ways, right? So through casting, which is a lot more efficient in terms of production and less requirements from both the growth, and it's a relatively more straightforward means of production of these like plant fungus composites. So if that has been scaled successfully, so there is at MoMA PS1, I think, in New York. There's been a hi-fi tower by the Living Studio, and they've done I don't know how, but like quite, I don't know, 10 meters or more, but it's from bricks, and it's been sitting outside for quite a bit, and it has been weathered. And of course, I mean, it is biodegradable, and one of the things we wanted from the beginning was not include like plastics or things that break down in way different time scales relative to ours. So, but that does mean that eventually it will break down. So the benefit of this production means, which is less straightforward than casting, right? The additive manufacturing does imply more constraints in terms of how the material behaves during production, how is it made, and the rheology, fluidity of being able to be extruded through a printer, and also in terms of but it does include, since the transformation is being made at a higher surface area relative to its volume, right? Because so the material is being transformed, so it gains properties of hydrophobicity and strengthening being bound by the network system in contact to oxygen, right? So relative to a cast in its volume, it has a lot more, it's more favorable, right? When put in a complex geometry that's folded and that has a much higher surface to volume ratio. So it does come with benefits, but then also with restrictions. But then, because then it's not the same type of material as one that's cast, it still needs to be tested as in what are its own limits in terms of wearing and tear and mechanical performance. We have been testing it in tension and compression, and we've obtained favorable results, but more only as relative to a fungus-free sample, not relative to other, known materials and construction. So I think mainly the main goal of the research project, as it's been so far, is to kind of to establish a methodology of working between the biological protocols and then the digital fabrication protocols, and then including architectural scale constraints, rather than kind of optimizing and coming with fixed concrete answers in terms of performance of the material, because there's a lot that can be improved, and it's a matrix of very high parameters, high number of parameters, right? I mean, when there's such an extremely high number of fungal strains, out of which only some are yet identified, and they have vastly different behaviors and growth morphologies, and things that they do to the substrate and themselves, right? The hyphae themselves have a very different property. So only that, I think, is kind of hundreds of thousands, perhaps, of strains, right? And which each could be a parameter in terms of the performance of a hybrid material ultimately. But there's also the substrate, the different components of the substrate, the humidity, other things, the growth time and the space. So it's kind of, it's hard to say, for in general, this kind of material, what are its properties? But I can only say that because it's such a difficult question to answer, it's also a very exciting avenue to follow, because the answers could be really amazing and surprising. And in terms of how much it weathers, like it's been maybe just a few months that the column has been embodied in space, so we don't know yet how much it needs to weather, right? Ideally we would like to test it and put it out, and then we'll have an answer, but it just came to be, so I guess we'll see how it weathers.
I also think it raises, I mean, the question and the way that the column or the process works raises some questions about how we look at, I don't know, sustainability or durability within architecture. And, we are very, very much hard-coded to think that a sustainable building is one that lasts, several hundred years. And of course, that's kind of how we've looked at things. And we are very much thinking through concrete with reinforcement. And that's kind of as architects. But in biology, and when we are starting to shift over to something which is fundamentally, a circular economy, maybe that's not the only way kind of to achieve. Maybe permanence is not the only way to look forward at these things. And of course, in biology, things, they live and they build up, and then they die and they decompose and they become something else in a completely circular system. And that's in a way where the fungus in this project just brings something revolutionary. And if you look at normal kind of recycling of just paper, something that simple, every time you recycle paper, you break down the fibers from the wood. And after a while, they're so useless, you can't do them anymore. And then you kind of burn them and you get energy out of it, and that's it. So even though it's recycling of paper is more cyclical than other things, it's nowhere near what biology does. But when the fungus come in, they kind of at a molecular level, they break down the existing structures and they rebuild new fibers from it. And and fundamentally, that kind of opens up different ways for us as architects to think about what is sustainable and how long lasting should things be. And we can have a process where we're literally using decomposition as a strategy for renewal in architecture. And I think that's that's mind-blowing.
Mm-hmm. No, I think, I mean, to me, the column really encapsulates, and now in this discussion also, it's interesting how the term scale has been popping up over and over again, and it really becomes like a container of all different scales. I mean, as a total entity, as an object of scale, basically. I mean, you have the scale of the microorganism, the scale of the column, you have the scale of the urban space. In this column, I think it's really fascinating how it could encapsulate such a complexity. I don't know if you have any comments on that. If we're thinking about scale, I mean, if we raise that term.
Yeah, I think it's definitely, I think, an important terms in terms of my research, and I guess our research. I think it's kind of that's actually quite a you know sensitive point, because I think that's in order to touch different scales and to to make them manifest in something that exists in our world. I think it's so important to be that scales comes on a quite a first plane almost, and I think we've even kind of developed a methodology of addressing that. We're looking at transscalarity, so how requirements and needs and potentials at each scale kind of affects and ripples through at other scales, right? Because we have the scale, of a quite small molecular, right, of kind of all the transformation, the extrapolymeric substances that are being secreted by the fungus that do all these chemical transformations in terms of binding, in terms of attaching to the substrate, and to scale up at the hyphae that are growing and binding the larger fibers together. And then we have we also have the scale of the nozzle of the printer, right, that deposits material, and then each layer of the printing process, and then how these are bound together by the hyphae as well. And then we have the scale of each element, each brick, as we call it, that needs its own time and process, like how it's being dealt, how we print it, where do we store it, and then all the things about the time it takes to grow. And then we have the scale of the column of how these after they're being produced and how they stack together, and then they form another scale, right, that is human scale and architectural scale, and then perhaps further than here, right, how these elements together come to form an architecture. And then there's lots of things that we hint at and things that we solved and things that we put in place through this, and lots of questions that it further opened of how can we improve it, what does this make sense, how does this make sense, and how can we move on from here.
I mean, and also, I mean, the scale of representation. I mean, representation in the urban space, I think, is an important part of the scale. And I mean, the geometries would be interesting to talk about. I mean, there you have a quite big surface kind of folded into a kind of dense kind of column. So there is a juxtaposition in scale also in terms of the cross section of the piece, right? So if you would discuss the geometry of this, I mean, where would you start? What is I mean, how would you talk about the geometry of this piece?
Yeah, I think there's different ways to look at it, right, and different way to understand it. Of course, I think maybe where it all started for us, right, it's kind of understanding the requirements of the material itself, right? This kind of access to oxygen, because right, every most living things require oxygen, right, in order to grow and develop, and kind of that very basic need. Kind of what does that mean for geometry, right? Because as architects, right, geometry is something that's quite important to us, just kind of our way of like navigating different things. So it's kind of, we came to the realization that actually geometry can do a lot for that, right? So increasing the complexity, folding things instead of having, and it's kind of, I think here we get to something quite interesting in terms of how we relate to space and geometry and kind of on architecture, right? It's kind of to kind of refer to Philip Beasley in terms of, right, of his reflections on entropy and how right, the classical, you know, traditional architecture kind of based on from Vitruvius, right, on Fermitas, and kind of how architecture like just the principles on conserving forces, right, being conservative of the distribution of forces, and seeing architecture as something stable and firm and rigid and tightly bound, right, and kind of how if we kind of consider entropy in the universe, right, and instead of seeing architecture as a way to resist decay and dissipation, right, and kind of instead of seeing entropy as pure decay, as perhaps, you know, a really fertile place where things can happen, and you know, architecture, instead of being so tightly bound, kind of give in to that dissipation and create interfaces, right, and allow for forces and flows to be exchanged and modulated rather than tightly contained. And so I think in terms of that, there's a lot of like how we refer to classical geometry in space, and perhaps that there's alternative ways to relate to that even in our architecture space. So yeah.
That I think is super interesting, and that is really something I think this exhibition raises. I think we could open up also for the floor to give comments now, like Gunnar or Theo. Is that your sister, Anna?
Yes.
Quite.
Theodora,
Yeah, Theodora. Yeah, hi. We met at the opening. But I think you're entering something very, very interesting here, Anna, when you talk about entropy and I mean architecture's relationship to these aspects of permanence that also David, I mean, raised. When I was thinking about that in relationship to the column, particularly, that if you think about architecture as what we talked about, I mean, in geometry, space, that's one aspect of architecture, right? I mean, the spatial aspects, which kind of derives from a very fundamental way from the discipline of architecture, which has to do with the perspective, the techniques of the perspective, the geometries, right? I mean, representations. But then also you have the cultural aspects of architecture, of creating shelter, the social dimensions in use and in construction, etc. And I was, you know, visiting the object and the exhibition. I was kind of thinking about, if you think about architecture in these two manners, the spatial aspects and the cultural aspects, you may say that, I mean, the spatial aspects here that has to do with geometry and representations was quite fundamental in terms of architecture. But the cultural aspect, I think, of your column has really been reconceptualized. I mean, because you don't only have the human being in the center. I mean, ever since the Renaissance, architecture has related to the human being, put the human being in the center of the discipline. I mean, the scale and the composition of the human being is kind of in the core of the architectural discipline. Even if you look at the most radical architectures that we have, I mean, Piranesi's prisons, for example, where the composition of elements and performances are impossible to comprehend, or Libes Wood's fight against gravity, they all still relate on the human being. I mean, the human being is in the center. But the cultural aspects of your architecture don't do that. I mean, I think they really radically reconceptualizes to include both human and non-human actors, because the fungus, I mean, the microbiology is kind of so much both implicit and explicit. And to me, this becomes really the core of the sustainability factor in in the column, because it offers a perspective that really goes beyond the anthropomorphic and enters into the area of the Anthropocene. Because it includes everything in the architectural design. And there, coming back to the idea of the entropy and of kind of changing our culture, the Western culture, how to think about permanence versus impermanence, where entropy, I think, could become a core aspect. I mean, we have had artists working with entropy since Robert Smithson, Gordon Malaclark, etc. But how do you think about shifting the perception of the discipline or the industry? Or, I mean, where do we start doing this? Is the exhibition on SPARK one momentum in this kind of approach, or how? How do you think about it?
I hope so. That's, I think, yeah, I mean, definitely, I think that's part of, you know, my agenda, at least, to kind of, to try to, you know, I think to get out of, you know, the difficult position that we are on the planet right now. Oh, hi. Little cute duck.
Here we have another biological organism. Actually, I could comment something about that if you don't have anything else that you wanted to say, Anna. I think that this idea of, you know, maybe thinking in terms of cycles of growth and decay and such in architecture is really interesting. I haven't thought about it before, but I mean, like, I totally agree that it seems like we're kind of stuck in some sort of thinking that things have to be built to last as long as possible, even if that's not necessarily optimal in the long run. So a really concrete example, you know, I'm on the board of the Faculty of Science, and we've been discussing a lot this moving to Brunnshög and building new buildings there. And oh, it'll be great, you know, it'll cost money, it'll be a big investment, but we can build them to be exactly the way we want. And it might not be, you know, in the end that much more expensive than staying put, because the buildings that we have, most of them are getting old and need to be renovated and that sort of thing. And so I'm thinking that we tend to have some sort of idea, it seems, that when you build a building, it's going to be used for this purpose forever and that needs are not going to change. But of course, that's not the way things work. I mean, you do need to reevaluate every 20 or 30 years, you know, at least just in the context of, you know, replacing things that are not functional anymore or wearing out or whatever. And to make that easier and to make that be a more natural part of the way we design buildings, I think would be really, really useful and really helpful. You know, the school here in the village that I live in, they're having to expand because they have more children. But I mean, you don't want to build it too big because at some point you might have fewer. And so to sort of have this be built into the system that you can, you know, expand and contract your buildings and change their usage over time as your needs change. I think that that's really exciting and really important for sustainability.
Yeah, that's true. That's such a good point.
Gunnar, please join the conversation. You are muted, Gunnar.
That's better, I guess.
That's better, yes.
Yeah, I think it's interesting that you brought up the time perspective, both Anna and Jessica now, because, I mean, usually in the world of architecture, 10 or 20 years, for instance, is a very, very short period of time as compared with, shall we say, art in general. But when we think about materials, I mean, how long did it take for us to know what to do with limestone, with cement, with concrete? How long did it take to develop that? So what Anna says about that, this is, we have to think about these experiments that you do, Anna, as something that is very much in the preliminary state of things. And that you kind of almost raise the question also, how do we live with fungi? How do we live even with mold? If we go back to this 10 or 20 years short time span in architecture, some houses today that are 20 years only old are torn down because of mold, for instance, in them. And what Ana does is also turning that issue around. Instead of being afraid of mold, how can we learn to not only build perhaps, but live with mold in a new way? These are very interesting questions, I think, that are raised by this project as well.
Mm. I completely agree, and that's something that I've been also thinking about when sitting in the gallery, how, for example, a facade is designed to keep everything out. I mean, like animals, like insects, like everything is supposed to be kind of prohibited by the construction by the design and then the configuration of a facade. But what if a facade becomes the nest for cockroaches and rats and stuff? I mean,
yeah, that's so true. That's such a good point. It's because I think also, in a way, cockroaches and rats, exactly as you gave examples for, right, are like the ultimate example of pests, right? Of pests that thrive in urban environments, and that's exactly because of in some ways our quite a deliberate control and eradication of everything else, of seeing urban spaces as only for humans, and of course that's not possible because life always finds a way to creep in. So because of these environments that are a lot more restrictive and less balanced, there's pests that thrive and multiply in very high amounts. But I think what you're hinting here, and I think that's also really interesting you're saying that, because it is our other research project that we're working on now. It's exactly kind of, what if we look at architectures that are not just for humans, not only in terms of how they're built, but also how in terms for livability, right? What if we open up cities for higher biodiversity, and can we make an ecosystem of that is more balanced and that can benefit other species as well? So I think that's a great thing to aim at and consider, right? At least.
I think we had a moment, a couple of months back, Anna, when we were talking about these issues, and just the realization that, in a way, like you guys are all hinting at, we are designing to exclude nature in a lot of our buildings. We're trying to make them uniquely for humans and nothing. And then we see all these problems with pests, whether they're rats or cockroaches or mold. But essentially what's happening is that we don't have a functional ecosystem. We have a monoculture that's, whenever we try to turn nature into engineering, whether it's in agriculture or in architecture or in healthcare, we see these problems. We try to exclude life, and then the life that comes back becomes essentially a monoculture that's dysfunctional and that it's not compatible with us. But if a wall isn't a nest of spiders and mold, but what if it's instead kind of functional ecosystem? There's all sorts of ways that these things work together, and that becomes much more compatible with human life. And that's why living in the forest, you don't have problems with mold. It's when you move into a house and try to exclude nature, that's when mold becomes a problem.
Yeah.
Just before this conversation here, I revisited an article by Andréen where he suggests us to skip the term function and instead talk about ecologies. And that seems like there's something interesting in that shift for architecture. I think what we're hitting at here, to start to think about ecologies in this manner. It's a radical change for architecture.
So I recently read a book called Biocultural Creatures from 2016, and that I think might be interesting for you guys to check out, to follow up on this sort of thing, because it's someone who was a researcher in the humanities who took a bunch of classes in biology, basically, sort of, coming from a different starting point, but wanting to learn more about biology, and talking about sort of post-humanism and how we can change our perception of the human by knowing more about our biology, basically, not just that we are our biology, but that that our thinking is shaped so much by this idea of, you know, dualism and keeping things out, and that, you know, my mind is one thing and my body is another, and that, you know, her thesis in the book is really that, well, even a membrane in a cell is not impermeable. You know, we have transfer of things all the time, but it's more about maintaining homeostasis. It's more about maintaining the, you know, the right sort of internal environment compared to the external environment, and that we should be thinking about sort of, yeah, the permeability of things rather than excluding things.
What was the name of the book again?
Biocultural Creatures.
That's a great reference, I think. Yeah, thank you. That's kind of, I guess, what we are trying, right? The discussions around, you know, permeability and exchange, rather than, yeah, binary positions and exclusion, and also, you know, ecology, I guess, looking at architecture as an ecology, because it is already, right? I mean, there are so many species living in our homes, but perhaps not the ones that we like to think of or want as pets. But yes, I think, yeah, there's some really, I think there's some great potentials that is now, you know, with also the advancements in technology, that we're able to understand and look at our world in the different ways, right? Perhaps with less fear and with more understanding and with more capacities to put things together and to yeah, I think there's a potential, you know, great ways opening up for, but I think in order for that to, you know, truly be effective, I think it needs to come with a change in perspective and how we relate to others and how we relate to our environment. I think that needs to be fundamentally, you know, changed and reflected upon. And I think that's when we can, yeah.
Gunnar?
Yeah, I had one question. I was thinking before how to connection the discussions about aesthetics with that of scale. That I know, Ana, that you have mentioned the notion of mesoscale sometimes, because if we by mesoscale mean a scale between what we can tactically or haptically sense as human beings and what we cannot really detect with our eyes, the micro scale. So between micro and macro, we can talk about meso. And these fungi experiments obviously are on a kind of, if you study them closely, they are on a kind of millimeter scale, perhaps. I don't know, you may correct me if I am wrong here.
Off a couple of
but they are also linked to the question, I think originally also asked by Jessica. What do you feel that you are in control of here in these experiments, and what do you let go as being in the control of the fungi itself? I mean, you could imagine structures where fungi has completely taken over, shaping quite different kinds of scale, maybe not columns in the sense that you sort of, how should I say, you support the fungi in a certain way to get oxygen, as you said, you could see in the mirror, the structures, they also strength in the column. But so on what scale do you think that you see the most interesting, how should I say, future experiments in these?
Yeah, I think that's a really good question. I think, I don't know. Of course, like, in a way I approached this project, I guess, with the desire to control, right? To kind of, to manage to, you know, to shape the fungus, I guess, in a way that it does what I needed to do. But I think it's kind of by learning and kind of, you know, because I started this journey without knowing much about biology or kind of microbiology or fungi in general. So it's been a journey of kind of understanding and, I don't know, eye-opening journey of such different behaviors and modes of it existing, that I think it became a lot more of a negotiation in terms of that. And as you're saying, I mean, generally, I think in any kind of project, there is a point of kind of letting go and of kind of things falling into place in their own way. But I guess when working with the living agents, I guess so much more, a lot of letting go and not just letting go, but things that we're unable to control. I mean, in ways that, you know, setting up experiments with exactly same constraints and same setup, and results turning out very differently, and us not being able to really explain or understand, right? Even working with biologists, that they were also kind of discovering things along in this journey. I think it's been, in a way, quite a humbling lesson as well, that, you know, there's that I think lies a lot of potential, right? I think as long as we don't understand everything, there's so much more to learn and, you know, grow into, right? It would be, I think it would be sad to find out we know everything there is and things are still as they are. So I think there's only room for good things in that, I guess.
I think control is a super interesting topic here, because I mean that is also in the core of the architect. I mean, using geometry to control construction of space, basically, and the level of control throughout the processes. I mean, I think the control in the mesoscale is really something that I bring with me. And the mesoscale, I haven't heard about that before. It was very interesting.
I think the notion of support is also extremely important. I mean, for architects and for construction philosophy.
Support, how do you mean, Gunnar?
I mean, in the sense that Ana is obviously also, by using the kind of parameters and mathematics that she uses, she is also in the enterprise of supporting the fungi, so as to give it enough oxygen at the same time as giving it possibilities to grow, so that it can strengthen a kind of structure, a specific.
Yeah.
Now we talk about control, and I find the notion of control and giving up control, it implies somehow that there's a possibility of knowing the vision of the end result and knowing how to prioritize between the human needs and the biological needs, or the process needs or the economic needs, whatever. And I think this process very much kind of starts talking about a different perspective, which is more about exploration than controlling. So, you know, of course, we had to take into account the oxygen that the fungus needs, and that led to a structure which has got this kind of particular geometry. But that also opens up all sorts of possibilities of you working with those flows of oxygen for the fungus as flows of something else in the architecture that might benefit humans. So I think, you know, if we say how many % do we do this for the biology and how many % for the humans, there's a risk of missing something. You know, if we're saying that actually it's for both, then it's a process. So it's not about controlling it one way or the other. It's about using this process to discover and explore, you know, kind of a new design space that might become something that wouldn't have, it's not between this extreme or the other one. It's something completely different that might be better than both of them.
Thank you, David. Perhaps you got the last word there. My watch is 2:59, and I don't know if Zoom just closes down here at 3 p.m. If it does, it does. But I think we reached the end here, and I really would like to thank Jessica, Abbott, and David and Gunnar joining in here, and of course Ana, who did the exhibition. Fantastic, it's been a fantastic, and it's 3 p.m. and it doesn't close down, so obviously there is some resilience in Zoom. This is also an experiment. I had no idea about the final outcome here. But I think that really rounds things up great, David. I mean, about the experiment, about the open-ended kind of processes that we need to work in. And there are so much that I'm taking with me from this conversation that has to do with scale, time, I mean, different kinds of scales, mesoscales, and thinking about control and support. Very, very good.
Yeah, it's been such a great, thank you so much for allowing so much, you know, time and space and around the things that I brought in with the exhibition. I think it's really so rewarding to me to kind of, to hear your thoughts on it and kind of how yeah, that hopefully, it does have something to bring to the world of, architecture and such things. So I'm very happy for your time and your thoughts.
And
Thank you.
Thanks, Anna, for just putting together the exhibition. I think, it's in many ways, it's got a really so much beyond the project before it. And I think it adds so much to it in the conversation that it creates and the questions it raises. I think it's an extremely successful exhibition. And I think this has been an incredible conversation that you basically entirely created out of that. Really well done. And thank you, Per-Johan and Jessica, for making this conversation happen.
Thanks for the invitation. It was really interesting.
Yeah, thank you so much, Jessica, for agreeing to come and and for participating.
I enjoyed it.
And
Okay.
Thank you for organizing. Bye. Have a nice evening.
Bye. Have a nice afternoon.
Yeah.
Ciao.
Bye.
Bye-bye.